Hello and welcome to StuffTV. I'm your host, Nick Huzar, and I'm also the co-founder of OfferUp. And I've spent a lot of time thinking about my own existence, how I impact the planet. I think it's something we all think about, and it's kind of a complex topic. So what I started to do was create this podcast and interview really interesting thought leaders to help enlighten us a little bit. And today I'm really excited to talk about Earth's most abundant chemical, hydrogen. And hydrogen contributes to about 75% of the mass of our universe. But how do we harness it in recycling? How do we leverage it for energy? It's kind of an interesting chemical. So I thought we'd have somebody enlighten us today. And with me, I've got Rostam Refschneider from Hydrova. And so thank you for being here, and appreciate you for taking the time and telling us about your company and how it's, I guess, touching on two different aspects of hydrogen to some degree. One of it is around recycling and how we can, eliminate some waste there, but also a byproduct that helps to create more hydrogen, if I'm not mistaken. So thanks for being here. And with that, would love to dig in a little bit more about your business and maybe explain to me how we got here.
Yeah, absolutely. So I'm Rostam, the co-founder of Hydrova. Hydrova enables zero waste recycling of aluminum production waste byproducts that are called dross and salt cake. We'll get into more of where those come from later.
It sounds tasty.
Definitely. It's nasty stuff. But Hydrova's technology transforms these dross and salt cake waste byproducts into valuable products that can be used in industry, including aluminum alloys, low carbon cement, and green hydrogen. Excited to talk about aluminum, cement, hydrogen. But first, so how we got started into all of this. So I was studying engineering and entrepreneurship at MIT. Always knew I wanted to start a climate tech company since I grew up in California, witnessing the effects of climate change in my home state, from droughts to floods to wildfires, you name it. So fast forward to my senior year at MIT, that was when COVID struck. So this was actually in April and May of 2020 during the height of the pandemic. Right at the same time, I got a grant from MIT to work on aluminum-based hydrogen production. So that was what started this whole journey. That led to learning more about the aluminum industry, all about the problems with dross and these waste byproducts that come from the recycling process, and eventually adapting our technology to include zero waste recycling in addition to hydrogen production from aluminum.
Maybe we could spend a few minutes just on aluminum in general, because it is a substance that, if I'm not mistaken, we can continue to reuse again and again, right? Like, I really hope I say this a lot about like plastic water bottles. This company Liquid Death, like hallelujah, everybody should move in that direction, right? Because we produce in 24 months, we will produce 1 trillion plastic water bottles. And so can you maybe take a few minutes and explain how your process works for the average person?
Absolutely. So to touch on aluminum first, aluminum is an incredibly strong and lightweight material. It's 1/3 the weight of steel, and that makes it be used widely in construction, transportation, packaging, many other applications. Aluminum is the most abundant metal in the Earth's crust, makes up about 8% of the Earth's crust. Of course, in nature, it's found as an ore and needs to be smelted, which uses energy. But once it has been smelted, aluminum is highly recyclable. So actually over 75% of the aluminum that we've ever made is still in circulation today. Recycling is super sustainable, takes only 5% of the energy that it takes to smelt aluminum from ores in the first place. And like you said, we're seeing lots of plastic packaging products be replaced with aluminum, like the Liquid Death cans, aluminum water bottles. All of this means that we're going to need to do more and more recycling as time goes on. The problem with recycling is that it creates this waste byproduct called dross. Dross comes from the top layer of molten metal in these recycling furnaces that are melting scrap. That top layer hardens and is constantly scraped off. And because we do so much recycling, which is great for the environment, millions of pounds of this stuff end up going to landfill every year in the US, which isn't so great for the environment. And Hydrova is on a mission to change that.
And you can see this on your website. It's just at hydrovatech.com, right? You have
Yeah,
this really good visual, and you see it just kind of getting scraped off. Um,
exactly.
and today, that just goes to landfill. Nobody does a whole lot with that for the most part.
So the stuff that gets scraped off of the furnace has a little bit of entrained aluminum metal stuck to it. Maybe 5 to 15% of the material will be actual aluminum metal. So 85, 95% of the material is not aluminum. It's mainly aluminum oxide. Right now, the dross will sometimes get processed to recover a little bit of that aluminum, but the rest of it will go to landfill. So 85, 95% of that stuff ends up being landfilled. Sometimes when there's not enough aluminum in there to make it worth processing, the dross just goes straight to landfill. Yeah.
Mm.
So in total, millions of pounds of dross or salt cake, which is what it's called after the aluminum's been removed from it, end up going to landfill every year.
Yeah, I always just think there's a lot of opportunity in our waste stream. Given how much the human population produces. We've grown. To give you an idea, I think since I've been alive, now I'm dating myself, but I think we've 2x'd the world population. And then now I know in the US, the average consumer produces about 125,000 pounds of trash in a lifetime. Right. And that's a lot. That's a lot of trash coming out the other side. And I think part of the challenge, of course, is kind of one of the things you're tackling is you got to kind of start to break these things up and understand like how can we reutilize our waste. I just think it's a big historically, I think a lot of this is piled up, and yes, we recycled and there's certain things like that. But I think part of the challenge is the whole extraction process and what can you do. And you touched on this a little bit around, cement. In fact, an episode I'm editing right now is around concrete, which, I didn't know concrete was the most used substance on the planet until I started, doing this podcast. But it seems like the same feedstock we've been feeding concrete is the same feedstock since we invented modern day concrete in the 1700s. Like we haven't really we thought like, what can we put into this? And so maybe, can you spend a little bit of time kind of sharing your thoughts on how Hydrova can potentially change how we think about, cement?
Yeah, absolutely. So yeah, cement is an interesting topic in terms of emissions and just, yeah, it being the most consumed substance by humans, the most widely used building material, and being so hard to decarbonize because the carbon emissions actually come from sort of burning these calcium carbonate rocks that releases emissions that's harder to electrify than other industries. So first, let's define some terms. So cement versus concrete. So most people sort of toss them around
Yeah,
interchangeably.
sorry, I did that, but I know they're two different things.
No, definitely, yeah. Which you must have learned doing the other.
Yeah, again, I
episode
didn't
on
know that
cement.
before. Yeah.
Right, yeah. So so cement, and I'm sure you'll explain this in the next episode too. But cement is the glue that holds aggregates like gravel and sand together to form concrete, which is the final finished product. So cement is made of also various ingredients, one of which being clinker, which is where the majority of the emissions come from. And one of the main four ingredients of cement is aluminum oxide. So what Hydrova does is we actually recover aluminum oxide from aluminum waste. That's the rest of this, material that's not aluminum metal is mainly aluminum oxide. Basically, the oxidized metal that has reacted with oxygen and hardened on the top of the furnace. We can take that and use it as one of the main ingredients to make cement that provides a low-cost, sustainable, locally sourced alternative to importing bauxite, which is where aluminum oxide would otherwise be coming from for these applications. We've actually formed a partnership with a company called CTS Cement that makes a product called Rapid Set Cement, which people might be familiar with, having seen it on the shelves of every Home Depot in the United
Like
States.
Quickcrete or something like that.
Yeah, essentially. So yeah, the
Yeah.
rapid setting cements use a lot more aluminum oxide than regular cement. Basically, the amount of aluminum oxide is what determines the setting time. More aluminum oxide makes it set faster. Less aluminum oxide makes it set slower. So these products, like Quickcrete Rapid Set Cement, they use a lot more aluminum oxide than ordinary Portland cements, and they are a great sort of off taker for these aluminum dross recycling technologies.
Yeah, one of the things I also appreciated digging into concrete a bit more was, when you travel around, you look at the buildings and they're all different. And I've always thought about like, wait, where's the, and it's really because my understanding is cement is like the core part. But then what happens is as cement's shipped all around, people are now mixing it with whatever that local substance is, right? That kind of then makes the concrete, which gives it different colors depending on where you're at based on what's in the earth. Is that correct?
Exactly. Yeah. So the
Yeah.
aggregate, which is the rocks that you're digging up from various parts of the earth, can vary depending on where you're located. Can also vary on what kind of finished product that you want. If you see a concrete that looks smooth, like it has no rocks in it, it
Yeah.
actually just has finely ground aggregates that are ground into a dust or sand-like consistency to get that texture.
One of the other things that your company also can do is create kind of a hydrogen byproduct that can be used in many different ways. You want to talk about that a little bit?
Yeah, definitely. So I'll touch on hydrogen in general, and then how Hydrova is approaching hydrogen. So most people know hydrogen from the classic story of the Hindenburg, which was an old
Yeah.
blimp that was filled with hydrogen and exploded. Of course, that sort of gave everyone, a fear of the
Yeah.
dangerous potential of hydrogen. But it also has incredible potential to provide a source of energy and be a carrier of energy because it's so volatile. So now hydrogen is being looked at to help decarbonize heavy industries like cement, like steel. It's being looked at for heavy duty transport, for aerospace. A company called Universal Hydrogen making planes that fly powered just on
Yeah.
hydrogen, which is awesome.
One thing on that company in particular that's interesting is that the founder of that company was the CTO of Airbus. And I think his aha moment was looking at some of our ambitions for kind of a cleaner future and, looking at aerospace in general and some of these targets. And I think his thinking was there's no way we're going to get there. We're not going to mass produce enough jets to actually get there. So how can we retrofit jets with a hydrogen alternative? And I think it's been, I don't know, a number of months now. I think he just did their first voyage up here in Moses Lake, Washington. It was cool to see, like a hydrogen powered plane. Like the only byproduct of that plane was water, and it was much quieter. And so I think it's a really fascinating thing. But I also think some of the challenges are just moving hydrogen around, right? Like back to the Hindenburg comment, so that's another
Yeah.
thing. And I know there's another company I've seen some people tapping into our natural gas grid. I think the U.S. has the largest natural gas resource and the reserves on the planet, and it's very abundant, and so it's everywhere. So there's companies trying to figure out how can we tap into that, and then closer to the source, can we convert it to hydrogen and then put it on planes and things like that. So sorry, since you're talking about that, I thought just some interesting things happening. But yeah, please continue.
Yeah, no, exactly. There's tons of new technologies, new applications for hydrogen that we've developed that are really, really exciting. But the key challenge is getting hydrogen to those applications to be able to fuel them. Where do we source the molecule from itself? How do you transport it? How do you store it? All of those really difficult questions. So right now, our hydrogen mainly comes from fossil fuels. It comes from natural gas in a process called steam methane reforming, or SMR. That basically takes natural gas, CH4, turns it into hydrogen, H2, but the C, the carbon, ends up becoming CO2 and going into the atmosphere, creating emissions. So one way to make hydrogen to prevent that is just taking the natural gas, doing SMR, and doing carbon capture. We call that blue
Sorry, what's
hydrogen.
that? What's SMR?
Steam methane reforming. So
Okay.
that's taking natural gas and just making hydrogen and releasing the carbon into the atmosphere. And that's
Okay.
traditionally today how we make the majority of the 90 megatons of hydrogen that the world makes per year.
Hmm.
And that hydrogen is called gray hydrogen, on the sort of hydrogen rainbow, they call it. There's all sorts of colors that identify how the hydrogen was produced. So gray hydrogen is from SMR with CO2 emissions. Blue hydrogen is what they call doing SMR with carbon capture. So that's basically doing steam methane reforming of natural gas and then just doing direct air capture, point source of that carbon before it goes to the atmosphere. Another interesting method is doing methane pyrolysis, which is more of an experimental technology right now, but it's basically cracking natural gas into hydrogen at really high temperatures and creating a solid carbon byproduct that can just be sequestered as a solid.
Mm-hmm.
And then, of course, there's electrolysis, which is green hydrogen, and that's using renewable energy and an electrolyzer to split water and produce hydrogen. So,
Mm-hmm.
to meet the future demands of hydrogen, which the IEA projects to double by 2030 to 180 megatons, um, we're going to need to scale up all of these renewable sources because the IEA also projects the amount of hydrogen coming from fossil fuels from steam methane reforming to decrease. So if the amount that we're making from steam methane reforming or gray hydrogen decreases, but the overall demand doubles, the amount that's coming from green or blue or other colors needs to drastically skyrocket. So
Mm-hmm.
we're going to need lots of electrolysis, lots of blue hydrogen, if we can do methane pyrolysis, as well as biomass gasification, landfill gas capture.
Yeah.
There's all sorts of sources of hydrogen, and all of them are going to need to get scaled up. So Hydrova's approach is to take the aluminum production waste and use that to do the aluminum water reaction and make hydrogen from any aluminum that can't be landfilled. So similar to other waste to energy processes, we basically take this waste byproduct that comes out of the aluminum recycling process and encourage it to split water and make hydrogen using aluminum metal rather than electricity. And then that solid aluminum oxide byproduct actually gets lumped in with our cement afterwards. So we not only make hydrogen from this waste, we also completely recycle it and repurpose it into
Mm-hmm.
valuable raw ingredients for cement production instead of sending it to landfill. So those
And
those are the
and
two. Yeah,
yeah, the two, and then you're partnering then with recycling centers. Is that kind of the idea, and how you get in there to you're doing this on site?
exactly. Yeah. So our business model is to partner with companies that are called secondary aluminum processors. These are companies that are buying the scrap from your local recycling center and then actually melting it down and making new aluminum. And they're the ones that have to deal with this huge dross waste challenge. So the two sort of prongs of this technology, the two areas that help them is one, not having to pay to process this dross waste and have it landfilled eventually, and two is also to be able to recover a little bit of hydrogen in the process that can be used to help decarbonize heavy industries like aluminum and cement without needing to be transported and moved all around. It's on
Yeah,
site, so it's just directly reused without needing to move very far.
yeah, yeah. I do hope a lot of this focus on climate gets people to really, it's awesome to see how humanity has evolved in the last 100 years. It's just if you go back, think where we were 100 years ago, and think it's just incredible. But I also think part of the question should be what can we do more locally, and let's rethink these systems that got us to here, and it's time to kind of revisit, can we do more things locally? And I just think there's a lot of opportunity. Like I always say, it's a sad state where we are because it's easier to get an item shipped to you from China than it is down the street. But there's all this stuff is down the street, and so I think it's harder though to figure out how do you get scale locally, how do you tap into these things. And if you think about, I guess, to that point for yourself, I know you're a pretty young company just trying to kind of get out there and get some traction. I mean, how do you think about scale? I mean, are you testing your product? Are you starting to test this in a few places? What are the bigger challenges for you as you think about, the next few years?
Yeah, absolutely. So with new processes, it's always a long time horizon to scale up new technologies like this. So we've been working on this for about 3 years since our first like proof of concept successful reaction, getting to make hydrogen through the aluminum water reaction. And where we're at now is basically wrapping up our first big pilot of the technology with California's largest aluminum recycler. So we spent almost 2 years in the lab developing this technology, doing the early stages of company building, fundraising, team expansion, all of that. And then for about the past year, we have been operating a pilot of our technology with TST Inc., California's largest aluminum recycler, demonstrating this zero waste process where we're actually producing aluminum from dross, producing rapid set cement in collaboration with CTS Cement, the cement company that we partnered with, from dross, and also producing hydrogen from dross. Yeah, that pilot has been successful, and now we're looking to partner with a major U.S. secondary aluminum processor to scale up this technology. Also in collaboration with the U.S. EPA. We got a grant from the U.S. EPA about a year ago to continue developing this technology, and they will be applying for phase 2 of that grant program in just about a month here, actually. But I think now is the time, and there should be a lot more companies working in this space because eventually we're going to reach a sort of fully circular society where all of the critical minerals that we have to mine to do our transition to sustainable energy will have mined enough, and we can sort of just recycle them and keep them in circulation to meet current demands. I mean, I'm talking like long time horizon, 2050 scale.
Sure.
But there will come a point where we've mined enough of these critical minerals, and the recycling process will be sort of where the industry goes. So I think it's definitely very smart to look ahead and start to think about how we can proactively design better systems that are set up to be able to transition to recycling when we've sort of extracted enough of these minerals from the earth.
Yeah, I think what you're talking about, I believe in that future too, where, if you think about, I always tell people, I forgot the exact stat. I think in the next few years, we're going to be at about 250 billion parcels shipped a year. And you think about that, like everything associated with that is crazy to think about. But it's not like you're shipping all of these things and they're just abundantly flying all over the place. No, what's happening is those things are now growing, right? They're just sitting in these urban areas and they're getting bigger. Like our homes are actually getting bigger in the US, but our families are getting smaller. More and more of us are renting storage units. Like what's happening is all that stuff, all those resources and that, it's just sitting and it's growing in these big urban areas. And so I think back to your point, like where Hydrova is playing an important part is like, well, how can we start to tap into this? How can we make it economical to get these things circulating locally? And again, I think there is recycling programs and things like that, but it's not the majority today. It's the minority. And so hopefully we can tap into those more. Well, as you think about, maybe just double clicking on that in the future, like what excites you over the next decade, whether it's your company or even other things that might not even be related? Like, are there certain things that you're optimistic about?
Yeah, absolutely. Well, first, I'll have to give a shout out to aluminum. Aluminum is an industry that gets me excited. The recycling rate of aluminum is better than anything else. And aluminum recycling is very real, very sustainable. And, we're helping make 100% closed loop for aluminum recycling, but still counting on the individual consumer to actually get that, aluminum can into the recycling bin instead of throwing away into the trash. So one thing that excites me is also sort of the shift in mindset. I think the new generation coming in is much more likely to have that mindset of wanting to, recycle these things and think twice before throwing an aluminum can in the trash, take the little bit of extra effort to separate it out, put it into the recycling. And I think the overall trend of this sort of generation wanting to care more about the environment and about sustainability is something that I get really excited about because there's also a tremendous amount of new technologies that are very, very powerful that if we could harness, there's tremendous potential for decarbonization in a lot of different areas. It goes from, agriculture to carbon capture to critical materials, batteries, renewables. The list goes on and on. I guess this is reminding me of a question that I was asked at a panel at South by Southwest about a new term in our generation that's being talked about called eco anxiety. Basically, it's when people have this sort of existential fear of climate change, which can be especially tough when you feel totally powerless against it.
Yeah.
And while I'm working, so my answer to the question was, well, I'm working very hard on aluminum, which is a very important part of a sustainable future. I have to trust that there's people out there like me working on all of these other aspects that I just mentioned, continuing this charge forward against climate change, and just covering all of the other areas that I can't work on myself while simultaneously working on aluminum. And I have to say, listening to episodes of StuffTV has been getting me absolutely pumped up about some of the awesome things that people are working on. And yeah, it's really incredible to be able to hear about the incredible work that these people are doing when otherwise might not have heard about it.
Yeah, and I agree with you. And I also think it's going to take everything. I think, what got us here is not going to get us there. And I think it's time, hopefully that's part of the motivation between even doing a podcast like this, is just to enlighten people. Take this complex topic and make it somewhat interesting, have a conversation, throw some visuals in there. And now I'm like, okay, now I get it. But I think where I was last summer, I'm digging in this topic. I'm like, it's so complicated. And I'm like, let's make this is interesting stuff. And so like, how do we make it more accessible to people? And then I think it's going to take everything, right? It's just like the whole Industrial Revolution. We created many of these things that were huge and had a massive impact. And the amount of innovation that came out of that was so incredible. So my hope around climate is we see that same kind of energy going into this space. And you see it, you see the amount of money that governments are putting into this. If you look at just venture capital in the US, like it's grown 20x in the last decade in this space. So I think you've got enough fuel there, I think, to be able to, attract some of the best minds on the planet to do it. Mm-hmm. And I think we just have a lot more data. And I've heard this before, I think, for the younger generation about this climate anxiety. And it's rough when you think about it, because, when I was a kid, everyone, when we talked about climate, it was kind of like, oh, we know there's better things we can do that just makes sense. Like, don't throw your trash out the window. Recycling makes sense. But I never had this belief in my mind that, man, when I get old, there won't be a planet. And I've heard this a lot from the younger generation. Like, that's what they freak out over. Like, I would freak out over when I was a kid more of, oh, I'm going to die of cancer or something like that, but not ever thinking that this planet wouldn't be here. And so I'm happy to see that people from a younger generation are feeling that, but also like someone like yourself doing something about it. Like, oh, I'm going to put my time and effort into actually driving this change, because it's hard. Anytime you're starting a new company is extremely hard. And so I applaud you for what you're doing.
Well, just continuing off of what we were just talking about, one thing you mentioned was that how now the data, we have so much more data around climate, it's so much more well understood. And that's a really big piece of it. Like, the U.S. hydrogen roadmap just came out 10 days ago, has a lot of awesome information for how we can accelerate this transition towards a cleaner future. And there's all sorts of roadmaps and plans about a lot of things, not just hydrogen, coming from the government, other international agencies. But that information isn't quite so easily disseminated to the general population. So I think that's why having platforms like this, where we talk about topics like that are so big and so important, that don't always get the media attention that they deserve, because they might not be as exciting as
because there's a 500-page climate bill.
Right.
I read some of the climate bill. I was like, yeah, no one's going to read this.
Right. So having people like us to actually bury our heads in it and then come and talk about it on a platform that's sort of on par with the other sort of forms of social media that our generation is consuming is very powerful.
Yeah. Well, I'm trying. It's just like anything. This is a startup in itself, but I really appreciate you for taking the time and digging into an interesting topic. So thanks again for being here.
Yeah, thanks for having me.